Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, I hope you can hear me. And first of all, welcome to this session. Good afternoon in Europe, good evening in Dubai and Middle East, and good morning in US. For those of you that doesn't know me, my name is Gonzalo Martin, and I am the Secretary General of ProtermoSolar. ProtermoSolar is the Spanish CSP Association. And today I have the honor to be with all of you and with these 4 panelists. The session of today is going to be, I would say, between 1 hour 15, 1 hour and a half. And we are going to go through the world and we're going to see what is going on in Middle East, in China, in US, and South America and Chile. When I mean what is going on, is that we are going to ask our panelists what are the current and the future CSP opportunities, but also we are going to have a second round of questions talking about technology, which are, let's say, the improvements that we have seen in the latest CSP projects. And the last section of today, the last 20 minutes, will be for all of you to those questions that you submit through the Q&A box. I will try to make as many as possible, depending on the time. No worries if you have to leave before time. The session, as you know, is being recorded and will be shared to all of you after, I don't know when, but a few days or right after the session. So just not to waste any more time, I think we can start with the beginning. And we are going to start with Alvaro Solana Cruz. He's the director of Abengoa for Middle East and Asia. I don't need to, if you are here and you know about CSP, I don't need to explain who is Abengoa. Otherwise, you wouldn't be here. Abengoa is doing many developments in the world. And Alvaro, I'm going to ask you to introduce yourself, but also I'm going to launch you already the first question. And the first question is a must. We know the Dubai plant is very famous. According to IRENA report, the Dubai plant has reported the lowest tariff, CSP tariff in the world, with $74 per megawatt hour. So I would like you to introduce yourself, but also please introduce all of us how is the Dubai project DIWA going on, and what is the current status.
Yeah. Well, thank you so much, Gonzalo. Thank you everyone for joining us, and also thank you for the ATA to organize this webinar, which is very well platform to present what the business is going on and what the companies in the business are doing. So, well, thank you, Gonzalo, again for the introduction. My name is Alvaro Solana. I'm the General Director of Abengoa Middle East, handling not only power, but also water. We've been in the region for the last 15 years, myself for the last 10 years, and we've been doing a number of projects in solar and desalination mainly. Because everyone here is interested in the CSP, I'll just focus our experience in the region in that sector. Before going to deeper project, I would like to also discuss about the first CSP plant that Abengoa did in the region, and not only Abengoa, but it was the first CSP plant in the region, which is Shams 1 in Abu Dhabi. It's a 100 megawatt plant that we developed, built, and operated along with Masdar in Abu Dhabi, and it was a landmark and a benchmark for the sector in the region. That plant had no storage, but it made us, would say, benchmark the technology, and for sure it had opened the door for the DIWA project to come up. No. Focusing on this project, the DIWA project, it's really an interesting project for not only for the region, but for the whole CSP technology worldwide, because not only because of the size, but because of the integration of different technologies on one single plant. The plant has a total capacity of 950 megawatts, which is included in the Mohammed bin Rashid Solar Park, which is a complex of different, I would say, IPPs of solar plants. Most of them are photovoltaics. So phase 1, 2, 3 photovoltaics. Then it came our plant, which is a CSP, and the next ones are expected to be also PV. So this Mohammed bin Rashid Solar Park comes in the program of Dubai 2030 plan to provide green energy to the grid up to 20-30% of its capacity. I think that they are doing a really good job to achieve these targets. So as I was saying, the plant is integrated in 3 different technologies. We're having 250 megawatt of photovoltaics. We're having 100 megawatt of CSP tower, and we've got 600 megawatt of parabolic trough, which is the latter is what Abengoa is doing in the plant. Sorry, yeah.
No, please go ahead.
No,
go ahead.
So what Abengoa is doing in this project is the parabolic trough scope, which is, as I said, 600 megawatt, and we are one of the technology providers of the whole plant. We've got other companies involved, which is Shanghai Electric, Bright Source, and we're having, I would say, a third of the plant. For sure, for us, it's, and of course, we have Aqua Power, which is investing in as a developer in the project. It was a challenge for us at the beginning, but we've managed, thanks to our project director, we've managed to finish the erection of the solar modules on time. Now the plant is the parabolic trough area is divided in 3 plots. We have already commissioned the plot 1, which has been already injected HTF in the tubes. We're starting to do the I would say alignment of the modules on the plot 2, because we were waiting for some of the contractors to finish some part. And we can say we're in a good timing of the project. So once it is finished, it's going to be an amazing benchmark for the CSP, for sure. Just to add,
Alvaro,
it has 15 hours of storage.
When do you think it's going to be completely finalized, the 700 megawatt in full operation?
Yeah. So now the tower is being finished between Bright Source and Shanghai Electric. As I said, we are commissioning the plot 1, so we expect that the overall 950 megawatt is going to be finished by the end of next year, to be on the safe side.
That's perfect. And besides this huge opportunity that is being there for a few years already, is there any other prospects into the region? I mean, what after Diwa? What is next?
Yeah, well, you know, with the one of the upside of this project is that we are proving that the best storage way, the best way to storage energy as of today is CSP, because we can manage better the dispatchability with a long PPA. We can achieve low tariffs, and of course with the good radiation that we have in here in the region, can be that can be achieved. So we are making all the clients know that batteries, yes, it's a part of the solution, but not the best solution as of now. And we're trying to benchmark the CSP storage. So in Saudi there are some projects coming, maybe 200, 300 megawatt. Of course, not at the size of Dubai, because maybe it's too big to be financed. But maybe a smaller capacity plants will be coming. Also, Oman has been planning to do so with maybe 200 megawatt. And also, what we're seeing we're trying to also explore further for industrial operations, not only for electricity energy generation, but for steam in the oil and gas companies like Aramco, ADNOC, PDO, that maybe they want to do some enhanced recovery, and we can use CSP for the same also.
Good. Let's see if those opportunities are mature and we see more CSP plants soon.
Exactly. And so once the plant is finished, the market will be way more aware of the benefits of the CSP with storage, and can be maybe the leverage to get more projects in the pipeline.
We will see that for sure. Now moving on, but still in Asia, we go to China now. And thank you, Alvaro. I will come back to you in the next session about the technical questions.
Thank you.
Moving on to China, we have today Andy Zhao. He's the business developer of Cosin Solar. Cosin Solar, maybe you knew this company with the old name, which was Subcon Solar. Those are one of the most active CSP companies in China doing molten salt towers, mainly. That is their main product. Andy, first of all, thank you very much to be here today. Please introduce yourself. And also, for those that are not aware, let us know who is Cosin Solar and what are your main achievements.
Okay. So, hi, dear fellow colleagues. Good day. This is Andy from Cosin Solar. Nice to meet you all. Thanks to ATA Insights for the opportunities to share ideas, and thanks to Gonzalo for the introduction. And please allow me to have a further introduction of Cosin Solar. We are a technology provider committed to molten salt tower CSP. In China, we are also involved in project development and investment. We have delivered the Subcon Delinha project, the first molten salt tower CSP in China, which is the third one in the world. Over the years, the performance is satisfactory. 100% reached the design. In 2020, we were awarded the Solar Paces Technology Innovation Award, and up to now, we are the only Asian company independently to have this honor. We are currently involved in 4 IEC standard drafting, especially as leader in the drafting committee of technology specification for tower CSP solar field control system. We are the only tower CSP sponsored by the World Bank China Renewable Energy Scale-Up Program Right now, besides working in China, we are also actively exploring opportunity with partners in the world market. Yeah, Gonzalo.
Thank you, Andy. And now the main question. I mean, China, for all of us that are not Chinese, it's always, to me, it's always an enigma. I never know what is going to happen in China. We see some very big announcements. Suddenly we see some tenders that happened last year. If I'm not wrong, I think there were a couple of tenders. Could you please let us know in brief how big is the CSP market, what has been the latest tenders, and of course, what is going on?
Yes, Gonzalo. And China has speeded up the promotion of CSP. I personally think it will become another engine of the CSP industry. Since last autumn, China has announced several IPP tenders of hybrid renewable projects with the CSP integrated. This is first because of China's commitment towards the decarbonization. Secondly, China has the largest installed capacity of PV and wind in the world. The penetration rate is quite high in the grid, which leads to the serious problem of curtailment and cause the losses for PV and wind investors. At the same time, the grid is in lack of peak power or dispatchable power. And this is why large scale of hybrid projects are proposed. In 2021, 5 projects totally included 500 megawatt CSP are awarded. The hybrid project of PV plus CSP and PV plus wind plus CSP are at the tariff of local co-firing power plant, which is around 5 cents US dollar per kilowatt hour. Yeah. And because many of the colleagues are outside China and maybe not very familiar with the Chinese market, and the people maybe have doubt that it's very hard to enter Chinese market. So here, regarding to the complexity to enter Chinese market, I'd like to clarify that Chinese market is not a closed or isolated one. There is no barrier to enter, actually. International players have contributed in the first round of demonstration CSP projects. For example, engineering companies like PSK and Edong have been deeply involved in CGN Greenhouse 50 megawatt parabolic trough CSP. Amangoa and CMI have contributed heliostat and receiver in Luneng project. SBP has provided heliostat in Hami project. Various equipment and materials from the international market have successfully applied in Chinese CSP projects as well. And investors like EDF and Anji have operations in China, although they have not tapped into CSP sector yet. And in China, the international investors are allowed to have the dominance in share structure. So this is what happened last year in China.
Thank you, Andy. One thing that is very interesting in China is that worldwide, the storage is, let's say, taken into account per plant. So, for example, in Spain, we need 6 hours of storage. In Chile, we will ask Fernando Navid, and so on, so on. But in China, what I understand, and please clarify that, is that you can create a park with PV, wind, or whatever, and the total storage requirement can be provided only by CSP. Is that correct?
Not only by CSP. Actually, the government mentioned that for PV and wind, this kind of intermittent renewables, they must incorporate it with some storage. And so far, most of the investors and the developers, they choose CSP as the solution because, except CSP, there is maybe like a battery, but a battery for the very huge scale, huge capacity and longer hours, it's not economical and technically it's not quite feasible. So most of the people, they will choose the most reliable solution, that is CSP. So this is why.
I mean, to me, that's a very intelligent approach from the Chinese government to start thinking also in the long-term storage. I think in some countries, such as Spain, for example, we are start to have too much intermittent renewables, and we need to think also like in China to also start including long-term storage. Okay, thank you, Andy. I think we're going to...
Gonzalo, yeah, one more, maybe I have one more comment. That's for the prospects of the Chinese market. So maybe people, they learn, okay, what's the last year, we already know, but what's for the next years? So maybe I'd like to add one more comment. Is that okay?
Yes, please go ahead. That's very interesting, of course.
Okay, Gonzalo. So as to the prospects in China, I'd like to share mainly 3 points. So first one, let's look back. As we have experienced in the first round of demonstration projects, all kinds of CSP technology are proposed, say molten salt tower, direct steam generation tower, beam down tower, molten salt-based parabolic trough, HTF-based parabolic trough, water-based linear Fresnel, and molten salt-based linear Fresnel. And up to now, 10 projects are in commercial operation, of which 7 molten salt towers, totally 320 megawatt, and 2 HTF-based parabolic trough, totally 150 megawatt, and 1 molten salt-based linear Fresnel, 50 megawatt. And my second point is, besides the 5 projects tendered last year, there are another 10 projects, totally 1,250 megawatt announced to be delivered in 2024. And quite a few more are in feasibility study. Among 1,750 megawatt CSP announced to be built, 80% are molten salt towers. And based on irradiation in China, 100 megawatt per unit is a common configuration. And my last point about the Chinese market is we all understand that CSP investment is very huge, and the investors need to minimize the risk involved in the development and the construction. And as we know, Chinese government is more centralized, which means in such a hybrid project case, all the related authorities will be coordinated to promote it under the same target. It's not a different parties to act individually, only to leave the investor with great uncertainties. So this is actually also the way Majan and DIVA act, and that is one of the most important factors contributing to the competitive tariff at that time. So to summarize, in China, great opportunities or gold mines are laying ahead for investors, technology providers, and also equipment vendors to explore. So that is all I'd like to share.
Just to confirm, did you say roughly 10 new projects until 2024, out of which maybe 8 will be towers?
Yes, according to the information I understand, it's like this. So most of the projects are molten salt towers.
In 2024, we will ask ATA to invite us again and to check how many of those are already there, but that would be great.
And in 2024, maybe I'd like to invite all the colleagues to China and we go there, take a look.
That would be our pleasure to go there. Thank you, Andy. Thank you very much. Okay, so now moving forward, now we go to US, to North America. We will have today Mr. Craig Turchi, please correct me in a bit. He's the CSP program leader from NREL. Again, I mean, if you are in CSP, you know NREL has been for more than 4 decades, 40 years developing CSP. They have made significant contributions from the R&D side, from a technical point of view, to commercial plants. And well, great. We are with this first question about markets. Could you please first correct me with my pronunciation with your surname, but also update us about the US market, because a few years ago, US was the second biggest market after Spain. We saw the biggest CSP plants in the world with parabolic trough, but also with towers at that time. And what is happening? What is happening right now in your market?
Thank you, Gonzalo, and thank you to ATA for the invitation. So I am Craig Turchi. I am a group manager, and I've been in CSP for about 14 years now at NREL. Many of you probably know my colleague, Mark Mijos, who was in this role as the CSP team leader. Mark has taken a position basically as a senior advisor for our CSP team, and the day-to-day operations of the team have fallen to me. So I feel very privileged to be stepping into that role that Mark has served so well. As you're correct, the CSP market in the United States has not been doing much in the last few years. We have about 1,500 megawatts of capacity in operation. And the largest of those plants came online in the early 2010s, as you alluded to, Gonzalo. So there are 5 big plants that were built back in the early 2010s. 4 of them are working remarkably well. Those include the 250 megawatt parabolic trough plants, the 3 towers of the Ivanpah generating station. Those are direct steam towers totaling about 377 megawatts. Those plants have shown year-over-year gains in generation and are operating at their design points now. The 5th plant and the newest plant is the Crescent Dunes molten salt power tower, which came online in 2015 and has experienced some challenges in getting up and operating reliably. It's 110 megawatts. It's got 10 hours of molten salt storage, so it has the largest storage capacity of any of the plants in the United States. And what we've seen there at Crescent Dunes, and this is borne out by a recent best practices study that NREL published a year ago, has been some challenges associated with understanding and staying within tolerances of thermal transients within the plants. I think if you look around the world, you know that we've got dozens of molten salt storage units operating very successfully at the parabolic trough plants. Those run at lower temperatures. And when we move to the power tower to take advantage of the ability to go to higher temperatures, we've seen some challenges getting those new plants up and running. And to put this in perspective, there's only a handful of molten salt power towers in the world, and it's a very young industry. And I think it's not unusual to see some growing pains associated with those industries. We do believe those are all solvable problems for a young industry. And what we'd like to see from NREL's perspective is greater communication amongst the developers around the world so that we can share some of the lessons learned and to the betterment of the whole industry in terms of reliable operations of the plants.
Thank you.
Now, that said, there hasn't been any new development in the United States. I wanted to point that out. It's been kind of a pause in construction in the US. What we've seen in the US market and in much of the world is that the original plants went in without much storage, and that was not necessary at that time. PV came along, of course, with a lower cost of solar energy as their costs dropped. And so PV in the US market and much of the world has dominated the utilities solar perspective. What we're seeing, though, as Andy alluded to, is now a recurring or a growing interest in storage. And in the US market, PV with lithium-ion batteries is still the winning technology if you need 4 hours of storage, 4 to 6 maybe hours of storage. What we believe is the future for CSP in the US market is targeting those needs of longer duration storage. And when NREL does a lot of future projection scenarios, I'm sure many of you know that. So our solar future studies looked out to 2050 and the desire to have a decarbonized electricity grid. And what we see there is that CSP comes back into the picture when we get farther down the road and to higher penetrations of renewable technologies like variable technologies like wind and solar. And the interesting thing in that study is that the analyst team created a generic renewable technology that provides firm capacity to the electric grid. It was a key thing in achieving these high penetrations of renewable energy. And the deployment of CSP was directly proportional to the cost of that hypothetical renewable combustion turbine technology, renewable CT, which means that CSP has a role to play because we need the kind of features, the kind of functionality that CSP provides to a high renewables grid. And of course, the question then becomes, will CSP compete with the other technologies that are also trying to make it into that marketplace? So I think that's where we stand in the electricity grid for the United States. I would like to mention the other aspects of CSP, again, that I think Andy alluded to, and that is the ability to provide heat. Maybe it was Alvaro that talked about this. The market for industrial heat in the United States and much of the world is comparable in its carbon footprint to electricity. And we see great potential for CSP technologies playing into that market, supporting industries like ammonia production, cement manufacturing, chemical fuels, mining industry, where they need heat directly and they need high temperature, high quality heat. And we see that in the United States with the emergence of a company like Heliogen, which is focused on that marketplace in particular, with the development of their advanced heliostat control systems. They are very much going after that market. They've got new agreements now with mining companies and some other industrial players to demonstrate their technology for process heat.
I mean, you mentioned a very important point. You said, and I fully agree with that, CSP at the beginning, even there are some CSP plants with no storage, because 20 years ago, storage didn't have this value, or just renewable. So I fully agree with that. Also, you mentioned, okay, in your projections, you see that you are going to need storage. We will see if CSP can compete. But somehow, what we see here is that CSP may offer some solutions to problems that they are not yet here, that are going to come maybe in the next, I don't know, 5 or 20 years, but they are going to come. Do you think CSP is going to be, let's say, still on business when those problems come? Or if we don't start building CSP, we could, start very little projects, the companies not having businesses, and when the problem comes, it's too late for us.
I think that's an excellent question, and I in the U.S. especially, I think that's going to be challenging because our CSP costs are higher in the U.S. just due to our market position and labor costs and things like that. So one answer to that is the industrial or the opportunities around the world that we're talking about today to maintain and grow the CSP industry. The other options are some of these other applications, like in process heat, where you're now competing for thermal energy, not for electricity. There are good opportunities for CSP there. And the spin-off technologies associated with CSP, when we talk about thermal energy storage, there are applications for thermal energy storage technologies without having a solar receiver and a solar thermal input. And that provides an opportunity for companies that have CSP technologies to stay active in the marketplace and to develop those technologies.
One thing I've seen in the renewable community is that somehow people tend to compare CSP with, let's say, PV, with other renewables. To me, that is a wrong comparison, because to me, CSP, and I take the example of Spain, should be like a nuclear plant or a combined cycle natural gas combined cycle. Which I mean is that they are very large infrastructure that they are strategic for the grid. CSP, as of today, cannot be financed on a merchant scheme. We cannot just close our financing of 500-600 million euros based on merchant. So we need the support of not the support, but some kind of a framework that provides stability. So in Spain, we hope we're going to see some tenders, actually very soon. We will mention at the end of the session, but very soon. And to me, it's like I said, as a nuclear or as a combined cycle, natural gas combined cycle, that we need some support just to be there when the problem comes. I don't know what are the prospects in US, if you think CSP needs to be, let's say, profitable today, or if you think the government somehow may support this development to avoid those problems in the future.
Yeah, I think we see in the U.S. market that there are general policies that are placed in to support renewables or low carbon technologies. Not so much specific call outs for technologies. The government doesn't like to do that. But we do see strong support in the research budgets for CSP. The US government has a $25 million demonstration of particle CSP tower and storage technology that's being led by Sandia National Labs. They have a $39 million project with Heliogen looking at the integration of the supercritical CO2 power cycle with CSP. And they have a large heliostat consortium now that they're funding at $25 million to help drive down the cost of heliostat design and manufacturing. So there's strong research support. I think we have a good probability of seeing support for plant development in some of the infrastructure bills that are currently in Congress and being discussed. But NREL as a research lab doesn't talk much about what's happening in the policy perspective.
Okay, thank you very much. Correct. I think we have to move on to Fernando González. Fernando, again, today we are talking with legends. He's also one of the most well-known names in our community, thanks to Cerro Dominador. Cerro Dominador has been the first CSP plant in Latin America, in Chile. It's a molten salt tower. Fernando, I'm going to ask you to present yourself, but also to please explain how or why Cerro is a tower and how you convinced at that time people to build towers and not another parabolic drone.
Okay, thank you for the introduction, and apologies for dropping out. And I mean, Craig talked about growing pains of the technology, and I have a very new laptop computer, and it crashed. So I was connected for an hour and a half, and it crashed when it was my time. So I'm sorry if you cannot hear me well. I'm joining with my iPad now. Yes, we Cerro Dominador, we have a tower, CSP tower, 110 megawatts, 17 and a half hours of molten salt storage. Why tower? As you probably are familiar with that map of the world that shows the best areas for CSP, and the northern part of Chile, where we are located, is the purple one, the best part in the world for this technology. The decision on going tower versus parabolic trough was actually made by Abengoa when they developed the project. The reason for that is the resource is so good and the air is so clear in the northern part of Chile that some of the concerns that you have with respect to tower when you have a heliostat that's located, I don't know, like 1.5 kilometers away from the receiver, is that if there's a lot of dust and particles in the air, then the efficiency of that heliostat becomes less relevant or more relevant. So you start losing efficiency. So with the clear skies that we have in the northern part of Chile, it's definitely the place in the world where you would like to put a molten salt tower. And that's what we did with Cerro Dominador, and that's what we are doing for our future projects. I mean, everyone has heard about the Licana name. That's a project that was originally developed by Solar Reserve that we acquired, that we are developed now. The project is ready to build. The concept is we will build 3 towers, and each one of the towers will have a capacity of around 230 megawatts and 12 hours of storage. And the reason for that is the difference is that we don't think it makes sense to build a storage for the sun hours.
Sorry, Fernando.
The best way to provide clean energy 24/7 is to start from a PV.
Fernando,
That's the cheapest way to produce electricity during the day, and then have a technology that can mold and adapt to that. And that's combining CSP with PV is the best way to achieve reliable 24/7 capacity. And basically what we will do in Licana is we will not generate electricity with the CSP during the day. We will heat the salts and produce power at night. But we will keep the CSP available for periods when there's clouds and the PV has to drop generation. So the combination of CSP and PV does not only provide in theory with 24/7 power, but in practice, when PV generation drops for some reason, then you can complement that with the CSP. So we think that's the future. We think Chile is blessed with the best best resource in the world. Unfortunately, there's no paradise on earth, and the having the best resource comes with some constraints, which is Chile is a very, very competitive market. There's no clear policy to
We are losing you, Fernando.
That makes us work harder and be more competitive. Sorry, if you are not be more competitive in terms of the pricing and options that we have. We think that what's happening today in the world, where issues in one part of the world can have a big impact in how markets are operating in the other side of the world, when you have to rely on imported fuels to run your system, you are subject not only to price risk, but also availability. And that's what you get. That's what you don't get when you plan for CSP. And again, if you're looking at decarbonizing the matrix, you have to look at options that can provide the same attributes that thermal units can provide, and that's CSP. That's CSP's role. Question is, will we get policies that provide the right regulation and incentives and market indications so for CSP to be deployed? We'll have to see. We're hopeful, and we think we're well positioned to capture that.
Thank you, Fernando. I'm very, very glad you mentioned Licana. As all of us know, there was a big announcement on press that Licana bid it at $34 per megawatt hour. We know that is not comparable with other CSP tenders because you are not bidding for the entire energy. You are able to sign PPAs at higher prices with private clients. But still, what is your view on that tender that Licana wasn't awarded at $34 per megawatt hour? And second, you said you are planning to build Licana with 3 towers, or around 200 something each. When do you think you're going to have this framework?
Yeah, thank you, Gonzalo. Yeah, it was interesting that with the price of $34, we did not win, right? So that's the beauty and the curse of the market in which we are operating. And it's interesting that we are seeing prices north of 100 in the spot market, and in some cases $300 per megawatt hour. But those were the rules. And that's why I think a change is needed, where these opportunities are not wasted and we don't miss the train. We have to make regulation today so plants can be installed in 4, 5, 6 years from now. So we need to start thinking forward on what needs to change so these technologies become a reality. Now, as I mentioned, this is a very competitive market. The rules of the auction were such that you can participate in different blocks, the different hourly blocks with different volumes of energy. So we designed the offer to make the most, to provide the most competitive price. There was while it was a 24/7 our proposal, the shape of the offer was such that there was a little bit more geared towards the day, and that there was a reason for that, and that's because we want to leave more energy uncontracted for the night, because that's when the energy will be needed. So it didn't make sense to offer a flat to make a flat offer when at very low prices, when we know that prices at night will be much higher based on how the market works. So we designed that to be aggressive. We wanted that to be the anchor contract to build our CSP. Unfortunately, we didn't win, but we'll keep trying, and we hope that the new auctions reflect more adequately the need for the electric system that will be needed for the periods in which the PPAs are awarded. So when will we have Licana? Just, I mean, give me a PPA and I'll show you Licana. Give me a point of where I can.
I think we need to tell ATA people to include also you and Andy in the 2024 session of this, and see you in a couple of years to see if there is.
We're doing our best. I mean, our plan is to find. We are participating in a number of processes, and we are confident that we have a very competitive offer, and we'll get awarded some, so we can start at least with the first phase of Licana, with the first of the 3 towers.
Because as of today, there is not public announcement of the next auction yet.
The auction has been announced, and it will be, I think offers are due sometime late June, early July, if I remember correctly. So the auction is in place. The rules are slightly better than last time, but really they do not, I mean, it's more of the same. The rules do not reflect the need for baseload power.
Okay, understood. And before we move to the next session, I would like also to ask about Cerro Dominador performance. We'd like to know how is performing this plant.
Good, thank you. Thanks for asking. And 2 caveats before I answer that. First is, for those of you who know me, I'm just an accountant, so just take what I say carefully. I've learned a few things, but I'm not an engineer. And second, I think it's good to talk about these things in these panels, in these forums. I've heard the most ridiculous things about what happened at Cerro. I'm happy to talk about that. And I think what we need to do as an industry is, we are all somehow connected. We know of everyone here in the 2nd or 3rd degree. If you have any question, please feel free to reach out, and we're happy to address that. But the worst thing we can do is just take rumors and spread those. So if you want to know what happened, reach out. I mean, I think everyone, I'm speaking for Cerro, which is what I control, but I think everyone will be willing to share what happened and how we make this industry better. We will not grow this industry if we keep just doing things by ourselves and not sharing the knowledge. And I think Craig mentioned the NREL study, and I saw some participants here that were part of that. I think it's great to share what went wrong so we don't make the same mistake again. That was very useful for that. There were a lot of lessons learned from other projects that were applied to Cerro. So we are not seeing some of the things that were of concern, that things that happen in other projects we're not seeing happen here, and that's because we shared the experience and we learned from that. Again, we had an incident at the plant in December. Basically, what happened is our system is slightly pressurized. The salt system is slightly pressurized, a little bit above atmosphere level, and there was and again, this is, we don't have the root cause analysis finalized now, so some of this may change, so be mindful of this, but there was an issue with the evaporator. One of the tubes of the steam generation unit broke, and as the system was pressurized, the mixing of the salt and the water created an overpressure in the system, and that's what affected the plant. I mean, the impact, having been 4 months away with the plant stopped, was not nice, but actually what happened was, I mean, you know that this, you have to, when you're working with this high temperature equipment, you cannot just turn it off and be working on that the following day. You need to respect some of the gradients. We had to get into a tank, review the tank, which was in great shape, but cooling down the tank takes, I don't know, 3 weeks, and then heating that again takes another 3 weeks. So the timing takes, things take time. I'm very pleased to report that the plant has, we synchronized the turbine last week. The plant is operating really, really well, as it was before the incident. I have to commend Abengoa for the design and the Abengoa Acciona for the work they did. We had a beautiful plant. We have a very robust plant, and we think that by showing that the plant can operate reliably and at high levels of performance, will provide comfort to people that is not familiar with the technology, and will be the catalyst for more investment on CSP. So we're back online, we're back strong, and we hope to continue like this. We have no reason to assume otherwise, and looking forward to keep generating electricity.
Thank you, Fernando. So just to finalize with this round of worldwide outlooks, I will quickly mention the Spanish case. In Spain, we will have CSP tenders. They have been delayed. They were supposed to happen today, but they're going to be, we don't know yet until when. I would say most likely after Spanish summer, so probably around September would be a sensible date. We will have 200 megawatts with at least 6 hours of storage. Also, in the rest of Europe, only Portugal has, I would say, a written energy plan, including CSP, for 300 megawatts until 2030. It's not yet clear when and how they are going to launch these 300 megawatts. And in Africa, we haven't said anything about Africa. In Botswana, has been already launched a 200 megawatts tender of CSP. And South Africa, I think today, they have released the 6th bid round I haven't checked yet if it includes CSP or not, but the rumors says that sooner or later South Africa will start including again CSP, that they are looking also with all of this grid stability. So moving forward to the second session, now we're going to start asking all of you more, let's say, technical questions. I also will include some of the questions we are receiving from the people. The first one goes to Craig. Actually, Craig, according to your experience at NREL, and you were mentioned before about the storage, about batteries, what are your views about thermal storage compared to batteries? You mentioned that batteries are competitive until up to 6 hours. I don't know, what are your vision here? And also, people from the public want to know what are the outlook for CSP for hydrogen production. If you see or you foresee that CSP and hydrogen could work somehow together.
Yes, so we're very bullish, I'll say, very confident that thermal energy storage has a role in electricity grid storage. Right now, projections are that the crossover point between lithium-ion batteries and thermal storage is somewhere in the 6 to 8 hours. For the audience, the significant advantage of thermal storage is the low-cost storage media itself. So when you want to expand to longer duration storage, you can add additional low-cost storage media, salt, particles, rocks, whatever that may be. And it's a very low marginal cost to move from 6 hours to 8 hours to 10 hours at the same production capacity. So that will always be an inherent advantage of the thermal storage technologies. And what we believe is that as the marketplace looks for longer duration storage, we're going to see a proliferation of these types of thermal or thermomechanical chemical, a lot of different storage technologies that are different from electrochemical batteries. I think lithium-ion batteries are going to remain a dominant force in the marketplace at low duration storage. There's likely to be advances in those battery technologies, but the nature of the electrochemical batteries will always have to overcome that linear cost projection when you go to longer duration. So the thermal systems will have an advantage there. These go by different names. People may have heard the term Carnot batteries. That's a reference to the ability to store electricity in a thermal media. We see companies around the world pursuing this. Malta in the United States, Siemens Gamesa in Europe. There are other companies pursuing other types of storage. I focus on the thermal because that's the one I think has the direct crossover from the companies that are experienced with CSP. So it's an area that we think is going to grow, and it's going to provide an avenue for additional revenue, additional expertise to be developed for CSP companies and CSP workers.
Thank you, Greg. And Alvaro, talking about PV and CSP, you mentioned before that in Zhao in Dubai, there is already a PV plant. What we have seen in the world is that there are several configurations. One could be a CSP plant plus a PV plant next door. Another could be a PV plant already integrated to your CSP plant. What are your views, Alvaro, regarding PV and CSP and how they are going to work together in the future?
Well, thank you, Gonzalo, for the question again. Well, there is no doubt that PV reduces the tariffs of the CSP plant. That is clear, and we all know that. As of now, CSP prices in terms of capex are way higher than PV. But of course, it depends also on the size of the plant. The larger the parabolic trough plant, the better we can optimize the price of the capex, and we can find the economy of scale better. And this is what we did in this project. That's why the tariff is so low, because we managed to too early to go in detail and try to reduce the structure of the modules and to find a most competitive capex. So as I was saying, the PV, the end reduces the tariffs, but also it depends on the VPA arrangements. So in this case, we have to see the project within the whole solar complex, the Mohammed bin Rashid Solar Park, as I said. In this PPA on the phase 4, we're having a gap of 3-4 hours during the day that we cannot generate, or the developer, Aqua Power in this case, cannot produce electricity during these peak hours, because we're having the PV plants, the previous phases, generating electricity at the time. So it is clear that there is an advantage of integrating the two technologies, because it can be, of course, we're generating instant energy during the peak hours, and we can save this energy to store and heat the molten salts and generate at night. So clearly, we are promoting internally to our clients the hybridization. We believe it's as of now, is the best way to achieve lower tariffs while the capex prices are getting reduced. Once, maybe eventually, we reduce a time that the capex is as competitive as the PV, maybe the PV is not required anymore. So that's in the future, we'll have to see what happens. But now it also depends. In addition to this, it depends on the purpose of the plant. As I was saying at the beginning, and also Craig mentioned, the industrial heat might not require PV, as we're generating steam directly and for other purposes, or maybe the enhanced recovery. So in that case, PV will not be required. So it depends exactly on the arrangements.
Yeah, I mean, there is a question on this from the audience asking that PV costs may drop even more using copper wafers instead of silver wafers, and they ask about how CSP will compete. I mean, I think, and this is my opinion, and you are the expert here, but I think that PV is already, as you said, the capex is already way lower than CSP. If they decrease the capex even further with other technologies or other new technologies, it's not going to change the fact that CSP will play a role into the market due to storage. And I think CSP, and Fernando was very clear on that, they are producing for Ilicana, PV plus CSP, and CSP whenever the sun is not shining. So I think CSP shouldn't compete with PV, but with the backup with fossil fuels.
Yeah. Market.
I also agree with that, Gonzalo. We don't really see CSP competing with PV. We see CSP competing with other storage technologies.
Exactly. Yeah, at the beginning, years ago, when we started to promote the CSP in the region, everyone was comparing with PV. Obviously, whoever is not very aware of the different technologies in solar, that they will compare it. That is because of they see the price is much lower. But the advantage of the CSP is storage, as Craig says. So PV, as of now, cannot provide this solution or this advantage because we have the bottleneck of the batteries. Once the batteries are developed further, as the CSP storage is now, we can maybe compare the two technologies. But as of now, it cannot be possible. Also, if you allow, Gonzalo, last thing, also it was important what Craig mentioned about the hydrogen. And there are, as you know, in the region, there are large hydrogen plants. There is a possibility that we are trying to get involved in one of the green hydrogen projects in the UAE. So this is also another application that maybe PV cannot, as of now, provide it because of this bottleneck of the batteries. Huh?
Well, I mean, talking about batteries, I would like to mention my point is that it's not only the cost. I mean, batteries has two constraints. One is the materials you need to manufacture the battery. At the end, if the world starts using batteries at a larger scale, we may have a shortage of materials. And second is the second life. What happened after 10 years time? What are we going to do with the batteries? In CSP, at least using molten salt, I don't see none of those problems. I think that molten salts are easy to get it, and the second life is quite straightforward. Just could be even as a fertilizer in the field in the country. So I mean, we focus a lot on cost, and we always say what will happen with batteries somehow are cheaper for 10, 12 hours. But still, I think it was Fernando who said that if you have dependence on third countries, on energy or on materials, at the end, you should invest on having your own independence in technology. So that's something we should also start to add to our narrative, that CSP is not only cheaper than batteries for the long term, but also we are not having those potential supply constraints and second life. Okay, thank you, Alvaro. Now we're going to go to Andy. Andy, I'm going to ask you a few questions from the public. Alberto, in the Q&A box, he asked about the capacity factor or the plant factor of the CSP facilities in China. And also, he and also me, I concur with this question. What about the startup time? I mean, since you build the plant until it reaches 100%, how long does it take in China to be at that level?
Okay, so thanks, Alberto, for your questions. And for the capacity factor, actually different power plants, they have different values. And this one usually also connected with the solar multiple, and also is connected with the economics of the power plant. So I can give you an example of our Supercon Delinha 50 megawatt project. So the storage time is 7 hours, and the capacity factor for us is 0.33. So this is our capacity factor. And for the others, if they can give us the actual generation, and we can calculate, but yeah. So far I only have our project's number. And you also mentioned what's the rate?
The time to since startup until 100% generation.
Okay, yeah. So around the world, internationally, usually it's like 3 years to reach 100%. Like the first year, the value may be quite low. For example, yeah, maybe quite low, and usually take 3 years. But again, in this aspect, I quite agree with Fernando that we need to share all the license and we need to share all the experience. In this way, we can reduce the time and we can quickly reach the 100%. I can give you an example that before we build Supercon 50 megawatt project, we already built a 10 megawatt CSP project. And in this one, actually we will accumulate a lot of license and experience. And based on this, we can quickly make the 50 megawatt go to the 100% to our target very quickly. For example, in the first year, we almost reach 93% or 94% if we don't consider the grid operators problem, almost 94.5%. So this is based on our experience and the lessons learned. So if as Financial suggested, the whole industry, we can exchange all the information and we will reach the 100% much quicker. And this benefit the whole industry. So that's my opinion.
Thank you, Andy. Regarding the capacity factor, just to give some numbers of Spain for Alberto who asked, In Spain, using real numbers for the complete renewable fleet, we do have for PV, it's around 13%. Wind is around 20, low 20s, 23, 24%. And CSP with the storage in Spain, our storage is not that long, it's only roughly 7 hours. The capacity factor is around 35%. Another question for you, Andy. I mean, I'm somehow surprised that in China, it seems there are many towers, but we don't see so many towers worldwide. One with Fernando, a couple of projects in US, and one, a small tower, molten salt tower, also in Spain. Why are also other towers using steam? Why do you think molten salt tower is not, let's say, more deployed? Is because the first CSP projects in US and Spain were parabolic trough, and somehow there was a legacy to keep doing whatever was already known, or why we haven't seen more molten salt tower projects worldwide?
So I'd like to contribute my personal ideas. So first of all, yes, indeed, there is a much larger installed capacity in the world for parabolic trough. And what is the reason? I think it's because, just as you mentioned, because parabolic trough is applied much earlier than tower. And why is that? And I think apparently parabolic trough is relatively easier in solar field control. And the accuracy requirement is not that high. And how about the tower? So again, let's take a Supercon Dalinha 50 megawatt CSP as an example. We have totally 27,000 heliostats to control at the same time. That sounds just like a nightmare 10 years ago. But however, after 10 years, I think the technology already made the breakthrough, and the world is very different now. And according to the CSP surveys and the DLR report, test report in Supercon Dalinha project, the tracking accuracy of the heliostat is excellent. So this is one. And on the other hand, we can see the trend in China and also in Chile. More and more towers are on the way, and the larger capacity is designed and to be carried out. So what's the reason behind how to compare parabolic trough and the tower? Actually, there is a report from Solar Paces on 22nd of March this year. There is a detailed report. So I don't want to waste our valuable time here, but I'd like to just highlight one point. With the same generation of electricity, the capex for tower technology will be 16% lower than the parabolic trough. And this is a significant and meaningful to achieve the more competitive tariff and thus to promote the CSP industry. So I think in the new times, we need to think in the new way. And about the comparison before parabolic trough, I just suggest all the colleagues, we can resort to Solar Paces 22nd March report. Thank you.
That's a very interesting data you mentioned, because sometimes technical improvement, for example, you said 16% cheaper. Sometimes those technical improvements are gone away, or they are eliminated by the financial constraints. I do remember Abengoa, for example, a few years ago, they made very new R&D products, but when they come to the market, the financial institution said, okay, this is maybe 10% cheaper, but to me, there's a higher risk from a financial point of view, so I'm going to charge you a more interest rate. So sometimes what we gain on the technical side, somehow we lose from the financial side. So in that sense, I think the moment we start seeing more molten salt tower, the interest rate will not penalize that much this product. So that is why we need you in 2 years to have 8 towers, and Fernando to have Licana as soon as possible. Thank you, Andy. Going back to you, Fernando, a couple of questions. One from the public, from Carlos Martin. If Cerro has any plan to invest in green hydrogen? And also have another question. From, you said you are blessed having the biggest radiation in the world. I agree. But also you are in the most developed and advanced electrical market in the world. Right now, I'm sitting in Spain. In Spain, we are facing that our electricity market, let's say, is not working properly. Let's say that due to the high prices of the natural gas, that prices is somehow matching or it's being allocated to all technologies. So nuclear or hydropower or PV is being paid at the price of natural gas during a crisis. So we are paying 300-400 euros per megawatt hour. What would be your, let's say, ideal market or electricity market scenario so that each technology can get the real value they provide? Because there is also a risk with this marginalist market. We also start seeing that in summer PV may face a problem because in the sunny days we start seeing a lot of demand, generation and low demand. So it's even an obstacle to PV to keep developing if we don't change the market. So those are the two questions: the hydrogen and also what's your ideal market.
Yeah, good. I'll start with the second, and I would say I'm sorry to disappoint you, but I don't have the solution to this. I think what you are saying is absolutely right. I mean, it begs the question: is the marginalist system still the best one to work on in a market that does not have the marginal cost of any new megawatt hour is zero. So I don't have the answer, but I think that's something that we need to evaluate long term. That's not something that you can change from one day to another. But I think we need to start having those discussions sooner rather than later. But as any tough discussion, I mean, when people tend to procrastinate. I mean, the fact that we still have a good, healthy platform of fossil fuel assets makes the tough decisions harder because, I mean, just changing the market means you're gonna disappoint someone, and why disappoint someone if you can continue doing what you're doing? So and again, hopefully some of the things that are happening in the world today are opening the eyes and of the decision makers here and full force these decisions. I think there are things that we can do in the meantime, which is having a correct allocation of prices to the services that are provided. For example, at least in some of the markets that I know, the capacity price is based on a thermal unit, and in most of the cases that results on a perfect incentive to install a diesel plant, right? So it's fantastic. It's a great model. You get paid capacity money for not running your plant, and then when you have to run, your variable costs are paid for. Now, what happens when you have a regulation that incentivizes the installation of diesel plants? Well, you get diesel plants, and then when you get so many diesel plants and you need them, then you start having the problems. None of the plants, or not all of the plants that have been collecting capacity payments, can operate at the same time. Why is that? There's no logistic, there's no capacity to move all that fossil fuel, all that diesel in the market. And then there's no drivers, right? So you don't have drivers to move the fuel, which is insane. And then you have paid for this plant capacity that you don't have anymore. So I think just looking at the capacity payment regulation is critical. It doesn't need to increase the price for the end user. It's just a reallocation of the capacity payment to technologies of the future that you are going to need in the future. Second thing is payment for reliability. The system needs inertia that's coming from the turbine at the CSP plant. How are you paying that? How are you giving signals for the installation of those things? There's a lot of talk about ancillary services, how you remunerate ancillary services. That's fine, that's perfect. I mean, having a right payment for ancillary services, it's a great, but it doesn't make, nobody will make a significant investment just based on unknown ancillary services. So, but those are things that start piling up and may end up in a better allocation of incentives to technologies that can provide that. And obviously auctions. Auctions, price is relevant. You have to have an auction that's based solely on price, but you have to allocate a portion of the energy to baseload power. You don't need to have 100% of the auction based on CSP or baseload technology. You just need a portion of that. Let's start with that. Let's get some of the baseload plants built and start proving that they can be a good solution here. And I'm not talking just about CSP. There are other technologies that should have to compete. Geothermal, pumped hydro, batteries, everyone has to compete, but just not designing the auctions to assign value to predictability and manageability of the technology. To me, that's a big mistake. Hopefully that's going to change. Now, with respect to hydrogen, we are looking at that with the opportunity to provide clean energy 24/7. That makes the electrolyzers be more efficient, as you will be running an electrolyzer 24/7. So I think there's a big opportunity. Chile has been very vocal and very aggressive in terms of our goals of green hydrogen. Everyone is jumping on the wagon of the clean hydrogen. I don't know how many of those projects will be real, but at least having the discussion will make some people pay more attention. I think there's a big opportunity here. I don't know if that's coming now or in the next few years, but having these analysis, these discussions is very relevant.
Thank you, Fernando. I fully agree with you regarding the market. The market must evolve, and we will see where is the direction it takes. We are almost running out of time, so now I'm going to give the floor to each of you just to make one final remark. I also want to appreciate all of you being here today. So let's start in the same order we introduce yourself. So Alvaro, please, if you want to say any final remark.
Well, I would like to thank you everyone for this opportunity. It's a good way to put together many ideas of the CSP. And of course, we believe in Abengoa that there is a bright future ahead with the improvement on the storage and the reduction in capex, and now the new applications in hydrogen and industrial heat. So I agree. I couldn't agree more with Craig and Fernando. Like the players should put together all the ideas, and we can improve on the same direction. So yeah, that's most of my takeaways.
Thank you
of the discussion. So thank you, everyone.
Thank you, Alvaro, for your time today. It was a pleasure. Andy?
Yes.
Thank you.
So, thank you, all the dear colleagues. And it's a very nice talk with all of you. And I think the world future lies in the renewable energy, and the CSP is no doubt is a very exciting technology and is very important in the future energy matrix. So I just wish all the power plant can work quite well, and in this way we can together to promote the whole industry, and in this way we will benefit everyone. Yeah, that's mine. Thank you.
Thank you, Andy, and I will see you in 2 years' time to show me your 8 new plants.
Sure.
Thank you, Andy. It was a pleasure. Craig?
Thank you, Gonzalo. So I already kind of said my takeaway. We don't really view CSP competing with PV at present. I mean, if you look now at what's being deployed, it's actually hybrid plants where CSP is working in concert with PV. So the challenge for CSP, as I see it, is going to be with other thermal or with other energy storage technologies. That's where CSP provides that benefit to the marketplace. And the opportunity space, the other opportunity is in providing heat for industrial processes, for chemical processing. We talked about hydrogen as one example. I mean, the world needs to decarbonize its heating sector as well if we're going to hit the targets that we need to hit.
Thank you, Greg, for being here today. Finally, Fernando, your last minute speech.
Okay, yeah, I think I spoke a lot, but I'm very optimistic. I'm very happy with what we are having at Cerro Dominador. So that's a good basis from which to build for new projects. One thing I did not mention that's also relevant here is the impact the development of CSP has in the countries. I mean, we've seen the impact in GDP and employment of the CSP industry in Spain. We think other countries can be, particularly Chile, can be a leading country in terms of developing industry and providing more valuable job opportunities for the local community. So that's something that's very relevant, and you may not get that with the rest of the other competing technologies. Thank you.
Thank you, Fernando. That indeed is a very good point. CSP has people working on that side, so it's not just building something and monitor from somewhere else. So you are very right. CSP provides a lot to GDP and also to local employment. Okay, so thank you to all of you. We were just on time, and just a reminder to all the people joining here today that you are going to receive the recording of today. And of course, all of us are more than available and willing to further discuss with you in case you have any further questions. So thank you very much. Bye-bye.